Okay, I just wanted to give you another chance at another example of how to identify all the trigonometric ratios given a triangle or given one of the trigonometric ratios. So we're told that cosecant of theta is equal to 9/7, right? And that means that is hypotenuse over opposite. And so we've got this triangle with a theta here. And so we know that the hypotenuse is going to be 9. Now note that the hypotenuse is the longer side that's across from the right angle, so don't mess this up. Don't put it on the wrong side. This longer side, that's 9. And then the side that is opposite of theta. Here's theta, so opposite means straight out. If you're not sure which one is opposite, draw a line from theta halfway through, just through the triangle, whichever, and then put an arrow at the end of it. Whatever it's pointing at, straight line out from theta, that is the opposite side. So this side here is 7, okay? All right, now, in order to get all these ratios, what we're now going to need is, we're going to need the length of the adjacent side, the side that is right next to theta. Well, to do that, we're going to need to use the Pythagorean Theorem, which is going to be a squared plus b squared equals c squared. Now we know that c is always the hypotenuse, so we're going to put a 9 in for that, 9 squared. And then the 7, it doesn't matter whether it's a or b, so let's just make it b, I guess. So we'll say a squared plus 7 squared is equal to 9 squared. So now it's going to be a squared plus 7 squared is 49. 9 squared is 81. Subtract 49 from both sides. And what we get now is a squared is equal to 32. And now we have to do the square root of both sides. And we get a is equal to the square root of 32. Now this square root of 32, it can be reduced a little bit. What you want to know is there something that multiplies to equal 32 that is a perfect square? And there is. 32 is the product of 16 times 2. And so now we can actually split that up into two radicals, square root of 16 times the square root of 2. Square root of 16, that becomes 4, and then the square root of 2. So a is equal to 4 square root of 2. So I'm going to come up here on this side, and I'm going to put 4 square root of 2, okay? And now we can identify all of our ratios. We know sine is opposite over opposite over hypotenuse. So opposite 7 over hypotenuse 9. So sine is just 7 over 9. Cosine is adjacent over hypotenuse. So that's 4 square root of 2 over 9. 4 square root of 2 over 9. Tangent is opposite over adjacent. So that's going to be 7 over 4 square root of 2. Now I'm going to bring that down here because here's the thing. We don't want a radical in the denominator, okay? So now we can technically have one, but I know that a lot of times you'll be in math classes where your professor requires you to rationalize the denominator. So we're going to go ahead and rationalize the denominator. Square root of 2 over square root of 2. 7 square root of 2. Square root of 2 times square root of 2 is 2, and 2 times 4 is 8. And so this becomes 7 square root of 2 over 8. So 7 square root of 2 over 8. Cotangent is adjacent, 4 square root of 2 over opposite 7, so that's easy. 4 square root of 2 over 7. And then last one is secant, and that's going to be hypotenuse over adjacent. So hypotenuse 9 over adjacent, 4 square root of 2. Let's rationalize that denominator again. So we're going to multiply by square root of 2 over square root of 2. Right? 9 times square root of 2 is 9 square root of 2. Square root of 2 times square root of 2 is 2. 2 times 4 is 8, so it's 9 square root of 2 over 8. And there we go. Now, you could then very easily, if we decided that the other angle was beta, you could identify sine of beta, cosine of beta, tangent, cotangent, secant, cosecant of beta. And what I want to remind you is that basically what it's going to happen is that these two are going to switch. So sine of beta is going to be 4 square root of 2 over 9. Cosine of beta is going to be 7 over 9. Cotangent of beta is going to be 7 square root of 2 over 8. And tangent of beta is going to be 4 square root of 2 over 7. And the same thing for secant and cosecant, they'll switch. Okay? So hopefully this gives you a better understanding. This one gives you another example and an understanding that the first time I gave you tangent, in this example I gave you cosecant. It doesn't matter which one of the 6 I give you, you can put it on a triangle and then find the third side with the Pythagorean theorem. And even if it includes radicals, you can still identify all the trigonometric ratios. Okay? Now we're going to move to using the trig ratios to solve real life problems.